The last problem on 7-5 is problem 6. It was not included in the note packet from last night, so we're going to do a separate video for it. And we're going to take all the concepts we've learned and we're going to just kind of combine them together. So problem 6 is using logarithmic properties, like the adding, subtracting, means, multiplying, dividing, to solve an equation. What is the solution of the log of x minus 3 plus the log of x if it's equal to 1? So our goal is to find what the value of x is that would make this equation true. So what we're going to do first is we have to remember, when the base isn't written, that we have a hidden base of 10. Now what I need to do, step 1, is I need to make these a single log. And because this problem has addition, I know that addition implies multiplication. So I'm going to take my log with the common base of 10, and I'm going to take x minus 3 times the other x. So I've taken my two logarithms, and I have made it one logarithm by applying the property rule. And that equals 1 still. Now what I'm going to do is, since it is now a single log, step 2, I'm going to make it make sense to me. I'm going to make it an exponential form. So make exponential form. Or you should maybe write put into exponential form. That would be better English. There we go. So I'm going to take my base of 10. I'm going to take my exponent of 1. Remember how it goes 10 to the first? And that is going to equal x minus 3 times x. Now we have a basic Algebra 1 problem. 10 to the first is 10. And on this side, when we distribute, we get x squared minus 3x. From here on out, again, we still have an Algebra 1 problem. You see that x squared? In Algebra 1, you've learned, whenever you see an x squared, set it equal to 0. Which means I'm going to take that 10 over, and it will now be a minus 10. Now you have two options here. You can either factor, or you can use the quadratic formula. Since this problem does factor, I'm going to factor it. So I get 0 equals x and x, and then the factors of negative 10 that make negative 3 when you add them are a minus 5 and a plus 2. Continue to solve for both of them. You would set each one equal to 0, and you get a positive 5 and a negative 2. Now what we need to do is just check and make sure that our answers are correct. So I'm going to go back to the original. I'm going to turn my calculator on and plug it in. Log of, let's try 5 first. 5 minus 3, parenthesis, plus log of 5, and we're going to hope to get 1, which we do. Now let's try plugging in negative 2. Log of negative 2 minus 3, close your parenthesis, plus log of negative 2. See how we get no real answers? That's because way up here, when we had an x all by itself, we're not allowed to have a negative logarithm. So for the original problem, negative 2 is not okay. Got it? Number 6. What is the solution of this equation using logarithms? So step 1, we're going to make it a single log, just like we did before. I know that a minus implies division. So I'm going to do log of 6 divided by 3x equals negative 2. You can reduce now, or you can reduce later. It really doesn't matter. I'm going to reduce later. Step 2, I'm going to put this into exponential form. My base is 10, remember. So I do 10 to the negative 2 power equals 6 over 3x. You again can reduce 6 and 3 now, or you can reduce it later. 10 to the negative 2 is 1/100th, so 0.01 equals 6 over 3x. We're now back to a basic algebra problem. I'm going to multiply both sides by 3x, and I'm going to get 0.03x equals 6. Divide both sides by 2, or excuse me, you divide both sides by 6. No, I'm sorry, divide both sides by 0.03. Let me make that more confusing. And 6 divided by 0.03 will equal 200. To check and see if we did this right, I'm going to take my calculator. We're going to go up here and check it out. Log of 6 minus log of 3 times 200 is -2. So we did it correctly.